So the effect to the shoots, we will see the effects to the shoots, the auxin effects. So if we have, just now we have that the auxin, the auxin produced at the tips, right? So we have shown that the tail is the part where the auxin is produced. So let's say we do some experiment on that. Okay, for example, for this pictures here, okay, the diagram here, we shows that if the lights come from all the directions, okay, this one is a normal situation. Okay, so the auxin is produced here, right? So the amount of auxin, okay, there's one properties of auxin, this one property of auxin where it will it will go away, okay, because this concentration is too high. Okay, if you remember the concentration, auxin, it needs like, even though it need high concentration and higher concentration at the shoots to grow, but too high is not really good, okay, or it's not stimulating. Okay, so it has to reduce the concentration. So one of the property of the auxin is it will go away from light. So if the light is here, so he will try to diffuse down, okay, diffuse down to the place where the light is not much. Okay, so it will go down, okay, it will diffuse down. So after it reach a concentration that is okay, suitable, then it will grow up, it will grow. Okay, this line will be the growing cell. Okay, we show in two-dimensional, 2D. So the growing cell grow taller and then taller and then taller and then taller and then taller. That is because of auxin. The perfect concentration or the suitable concentration of auxin will cause the growth, you see, become longer, okay, higher or taller. Okay, since auxin, or how to show that auxins do not like the light, okay, or will run away or will get to a darker side. Okay, so we can explain like this. Okay, if you remember phototropism, okay, phototropism, so this is one of the a good way to explain about how hormone affect phototropism. So if you see the light is over here on the left, okay, so since auxins, okay, will tends to diffuse to a darker side, okay, the shaded side. Okay, so when the light is here, okay, the auxin will diffuse to the right. Okay, when the light source come from the left, auxin will diffuse to the right. Okay, so you see this picture, the second picture. So from the part or the synthesis area, the tip, okay, now more of the auxin is accumulated at the right hand side, okay, instead of the tips. So how we explain this? So if you see here, this part, okay, this one, if we see, this part is shorter, this is longer. Okay, that's why phototropism means the shoot will grow towards the light. This one will make the shoot grow to the left, okay, because the light comes from the left. But what makes it grow to the left is because the right hand side of the stem of the wall or the cells, the right hand sides grow faster due to the auxin. So when here grow faster, here grow slower. So at the end, the result is it grow to the left. Okay, can you understand that? Okay, this part grow faster, the cell grow faster, here grows slower due to auxin diffuse to the darker side or the shaded region, or the shaded side. Okay, so it will promote growth. Auxin, the function is to promote growth at the tips, okay, or at the tips. Okay, so this is another example or another explanation. This is word explanations. Okay, I need you to understand it. Okay, or maybe you have to write it in your exam. Okay, the word. Okay, how to write everything in word. Okay, so you must say where's the light come from, how the auxin behave. Okay, auxin will accumulate at the darker side of the meristem. This is one of the properties. The first properties is the function. The first function of auxin is to promote elongation. Okay, the second one is different concentration is needed. Okay, different concentration is needed at different parts. For example, the shoots you will have higher concentration. At the roots you will need lower concentration in order to have maximum growth of roots or the shoot. Okay, different concentration needed at different part. That is the second one. The third one is acid will go or accumulate at the darker side. Means the part that is not shine by the the light. Okay, so this is another example of experiment that we can do. Okay, to show that auxin is responsible. Okay, auxin is responsible for the growth. So you see the first example here, first experiment, first set, it cover up with the foil, aluminum foil, cover up so that there is no light. So when there is no light, okay, the growth will just, it will not affect by any growth, right? It's like how to say, the concentration will be evenly distributed. Okay, so it will go up. Okay, go straight up. Okay, that means there is no effect. Okay, the second at this one no light. The light is because it's covered, so it doesn't matter whether the light come from here or there. Okay, just to show that this one is constant. When the light come from the right hand side, okay, if I cover it, okay, the auxin will not affected by the light anymore. Okay, because there's no light involved. The auxin is already blind. Okay, it's blind by that foil that we covered, so it will just grow upward as if like no light, or like as if like the light is come from every direction. Okay, all right. The second example is if I take the alga block. Okay, alga block, then the alga block is representing the auxin. Yeah, okay, so the alga block, even I put sorry, this one is even I put the alga block. Okay, this light, the auxin is still can diffuse. Okay, it's still diffuse, and it can even diffuse down or at the side or to the side away from the light, so the shoot is still bending to the right. Okay, where the light is coming. Okay, and then last example is you use the mica plate. Mica plate is to stop the diffusion. Okay, to stop the diffusion of auxin. So you see the growth of the growth of the coleoptile stop. Okay, remember, this part on top is the production of the auxin. Okay, so even though the auxin is produced here, it has to move down to the zone, to the elongation zone, to become longer. So when we put the plate here, the mica plate, the diffusion cannot happen. Okay, but we put alga plate, yes, it can diffuse. Meaning to say, auxin is a chemical, is a liquid, where it can diffuse from one side to another. It have something we call the concentration. It can diffuse from higher concentration to lower concentration. These two is to show that there are two things here lah. One thing is to show that the auxin, okay, can diffuse, okay, from up to down through the alga blocks. Okay, the second thing is it shows that the longer part, okay, the auxin will diffuse to a darker side. Okay, diffuse to a darker side more, so the darker side will grow faster. Okay, so there are two things here. One is diffusion of auxin to show is something that can be diffused, and second thing is to show is move to darker side. Okay, darker side. Okay, now we see the effect of auxin on the roots. Okay, for the roots, okay, about the same. The explanation is also the same. It will promote growth, but now we will see that the same concentration, since it's produced here also, okay, produced at the tip, and then on the shoot of the tip of the shoot and tip of the roots. So the roots also, they will produce some auxin. They will produce auxin. So the place when they produce auxin, it diffuse up. Okay, going up. Now since now, it will grow to the darker side. Okay, here we never see, there's the light. Okay, so the light as if the root is not in the soil now, is exposed. So we put the light over here, so we can see that this one, the auxin produced. So The third properties we says that the auxin will diffuse to a place darker one, okay, to a darker side, so it will diffuse to here this side, okay. And then in the root, since here concentration is higher, here concentration is lower, okay, remember in roots we need lower concentration in order to grow faster, okay, still growing here, but here is growing faster because of lower concentration of auxin, because this concentration, the lower one, is the best for the roots. We have seen the graph, okay, so the shoots will need more, okay, but the root need a little bit to grow faster, okay. If it has too high, it's something like inhibits the growth, okay. So when they go to the darker side, okay, so the roots, this is the roots, okay, this part will grow slower, this one grow faster, so it seems like the roots is phototropism negative, it grow away from the lights, can see, okay, things that you have learned, explain now, okay. So you have learned phototropism positive is for the shoot, why? Because of auxin. Phototropism is negative at the roots, why? It's also due to auxin, okay, due to the concentration. So remember there are three things about auxin, okay, please, okay. So there's another experiment where we can put the seedling, okay, we can put it horizontal or we put it vertically, the shoots here, then the roots here, okay. So after some time you see the shoot automatically will grow up and then the root will grow downward, okay. And this one also the same, even though I will put horizontal, the shoot will grow up, the roots will grow down, okay. This is also auxin, okay, so this is the explanation in word, you just read off, okay. So we have to go to the last one. So there are two hormones in plants, okay, one is auxin, another one will be ethylene. So ethylene is a gas form, so it's not much, we will not explain too much on that, this one because it's a gas, it's actually very hard to do with experiment, so we can show that it is doing something, okay, something to the plant. This is the one, okay. So ethylene, okay, it will help in ripening of the fruits, okay. So this one, the important is here and how you explain the auxin, okay, due regard to those tropism, okay. So we will stop here, thank you.